Okay, it's 10 o'clock. Hello and welcome to this last in this year's series of webinars. So today I'm going to be talking about Civil 3D and how to design superelevation. So my name's Ian Robinson. I'm the infrastructure consultant here at Graitec in the UK. I help customers get the most out of their infrastructure design and BIM related software. So that means I spend most of my time training and consulting. Normally I say traveling around, but I've done not a lot of that this year. But I also do a bit of support, webinars like this one's, workshops, blogs and customer presentation and social media. Very little social media at the moment. Generally, I evangelize the technology and make it work in the real world. So my focus is Civil 3D, Map 3D, InfoWorks, Recap for point clouds, Navisworks for federated models and clash detection, and also BIM 360. Graitec, we're a well-established company, having been in business for over 30 years. We've established ourselves as one of the largest Autodesk partners in the world. We're a software developer, and if we combine our own products with the Autodesk portfolio, that uniquely places us in the marketplace that you work in. I've got over 100 staff in our research and development centre working on class-leading BIM solutions that we provide. We've also got over 200 industry consultants just like myself. Our products are used in hundreds of thousands of projects every year, and we've got an excellent support record with over 50,000 cases, and we've delivered over 3,500 training courses per year. There's 4 pillars to what we do here at Graitec. We create, simulate, fabricate and manage. So we work with the Autodesk portfolio and our own Power Pack enhancements to aid the creation of construction and manufacturing deliverables. We then combine this with the use of our simulation products to verify those deliverables, and that enables us to drive them into the fabrication process where we also manage them deliverables. We've got our own CDE products. We link to internal and external platforms. And this webinar is very much in the create phase of the project using Civil 3D. This is the last in this round of workshops and webinars. So if you've missed any of the previous ones, you should be able to see them on the on-demand portal. Last week's hasn't gone up yet, but it will be there soon, I'm sure. Keep your eye on the events page of our websites for all future events. This is a clickable link, so if you go to the handout area of the go-to software, I've given you a PDF of this presentation, and you can just go and click the link. For past events, visit the on-demand page of our website. Again, that's a clickable link. Save you writing the address down and stuff like that. Just download the presentation. While you're on our website, don't forget to subscribe to our blog, and you'll see all the important updates and useful tips and tricks. If you want a little bit more, then we do offer a training passport. So this is a single fee that allows you to attend an unlimited amount of training courses throughout the year. So if you want to attend a civil course and maybe a Navisworks course or maybe an AutoCAD course and a Revit course, then you can, all with a single fee. Now, because you've turned up to this presentation, if you just make a note of that code, WEB102020, you'll get an extra 10% discount. So there's £100 extra to give everybody a Christmas bonus. Spend it on beer if we get any pubs that are open. I think most of us are going in to lockdown, aren't we? Let's just do a very quick poll. Got some questions here. Let's just get that launched. They're slightly different, or some of them are, to previous ones. What do you use Civil 3D software for? Now you can tick multiple answers here. So highways design or maintenance, landscape design, energy infrastructure, residential housing and commercial buildings. I just use it as AutoCAD with a few bells and whistles on it. Or you don't have Civil. If you don't have Civil 3D, just leave it blank. And we'll see how we go. Let's have a look. Okay, most of you have voted now. I'll close that in a second and then I'll share that with you. Interesting results. Right, I'll close the vote now and share that with you. So I'm trying to work out the numbers there. Oh, of course, because you're multiple selection. I was looking at the numbers thinking that's a bit weird, but no, multiple selection. So yeah, most of you are doing highways design, bit of landscape design, not many on energy infrastructure, okay? But of course, this is about superelevation, so I'm guessing that would make sense. Quite a lot of you doing commercial and residential building work and quarter review, just use it as extra bells and whistles. Okay, thank you for that. Let's go to the next question. Always useful these, just to get an idea of who's in the virtual room, if you like. So which Autodesk software do you have? So if you've got the AEC collection, Civil 3D, AutoCAD, or any variant of AutoCAD, so AutoCAD Architecture or Map 3D. Do you have Revit, or you don't have any Autodesk software? And I can't remember if I put multiple answers on there. I think I didn't, and I should have done. My mistake. If you can't click more than one, I apologise. Nice to see nobody's not got Autodesk. Although it's good to see when people haven't got Autodesk, because they're obviously coming to the webinars to see what things will do. Right, that's it. Everybody's voted who voted last time, so I will close the poll now and share that with you. So most of you have got the AEC collection, which is great to see. A few of you just got the Civil 3D and just got the AutoCAD. No Revit users in here. Again, the subject matter, that kind of makes sense. Let's go to the next question. There's only 4 questions today. Do you have InfoWorks? So yes, you've got it and use it all the time. Yes, you've got it, but you've never used it. No, you don't have it, or you don't know what InfoWorks is. Just tick on them. By the way, if you're an AEC collection user, you do have it. And if you've never used it, then tick yes, but you've never used it. Okay. Oh, a little bit more of you voted this time. That's good. Thank you. I'll close the poll in a second. Close it now and share that with you. So just under a quarter of you are using it all the time. A lot of you have got it but never used it. Some of you don't know what it is, and some of you just don't have it. Again, if you're doing infrastructure or using Civil 3D, InfoWorks is a fabulous add-on. It's a companion product that works really well with Civil 3D. So if you're working with LiDAR data, it's brilliant with that. If you're working with point clouds, it's really good for that. And it's great for doing preliminary design and also sharing your final designs or your design at any stage. So go and have a look at the webinars on the Go to on-demand page, should I say. Have a look at the webinars on there, and I think you'll find that really useful. And then the last one, what is your primary role? So are you a civil engineer? Are you in architectural, structural engineering, landscape architecture, or other? And while you're voting away, I'll take a slurp of tea. Okay, most of you have voted now. Give you one more second. Okay, I'll close the vote now. Okay, so it's good to see architectural guys here, so welcome. And the rest of you are mainly civil engineering. And again, the subject matter of this makes sense. But yeah, great to see architectural guys in here. Cool, thank you for that. Let's move right on. So this webinar is suited for civil engineers who need to design roads with superelevation. I'll look at designing a kind of major scheme using DMRB standards, and then we'll apply the superelevation. And then I'll look at how we can just simply swap a crossfall. You know, maybe you're doing a housing scheme and the lay of the land makes it more obvious to have a single crossfall at one stretch of road and a crown at the other stretch. So we'll have a look at that as well. So it's not going to be an awfully long webinar. I shouldn't overrun. It should be nice and simple. But before we start on the alignments, there's a couple of things that need setting up. Firstly, your assembly. When you make a new assembly, you need to tell the software what type of road you have. Is it a single or a dual carriageway? Does it have a crown or has it got a single crossfall, i.e. a planar road? If you're doing rail, it's a totally different thing. That's cant, so that's a different geometry. So you need to pick rail if you're doing rail. If you've got the US language version installed, this will say undivided and divided rather than single or dual. But functionally, if you've got that installed, don't worry. As long as you've got the UK country kit, it's not a problem. You can carry on working just with a different language on there. Subassemblies next, and your carriageway subassembly must have super elevation switched on. When you add your subassembly in the properties, make sure that you've said yes to the super elevation area. Okay, I'll just expand that a little bit. You can set it at any time, you know, after you've made your assembly, you can just go and select it and go to the properties and turn it on there. You can select all the sub-assemblies to change them in the properties at the same time. Remember, use the select similar sub-assemblies, not the normal select similar. There's a select similar sub-assemblies, and that'll pick all the carriageways, and then you can go and turn on or off the use super elevation. So they're the kind of two main prerequisites for doing super elevation. If that's switched off, it doesn't matter what you do from here on in, it won't work. Okay. When you make your alignment, if you want Civil 3D to calculate your super elevations based on design standards, you will need to tell it the road speed. You do that in the Design Criteria tab when you're on your Create Alignment Layout window. Like most things in Civil 3D, again, you can change this at any time in the alignment properties. Just go to the alignment properties and there's a design criteria tab. You can also, while you're in here, set multiple speeds along an alignment, because that's what happens in the real world, isn't it? Now, one of the most important aspects of any software is control. You must not relinquish any design control in favor of software automation. What you want your software to do is to allow you to be in 100% control. And what you want it to do is let you design, choose your standards, and warn you when you play outside of these standards. And this is what it does. It will tell you that your road design speed, so let's take an example. Let's say your road design speed is 60 kilometers per hour and you're working at a 2.5% super elevation. Then you go and design a horizontal curve that's less than standard. Let's say you set it at 360 radius instead of the desired 510. It will tell you in more than one place. It will tell you what you have designed and what you should have designed so you can correct it or mitigate against it. Civil 3D has the design standards built in, but these will only be your country standards if you have installed the country kit. For the UK and Ireland, install the UKIE country kit. It's a really big document, and the last thing you want to be doing is writing all that document just to save you installing the country kit, which is literally a 5-minute job. I say a 5-minute job, it is a 5-minute job. I am aware that some of you have to wait for IT to do it, and that could take a little bit longer. But trust me, if you haven't got them, you'll be working to US standards, okay? So make sure you do that. Now, these design standards, they're based on the proper equations used by the DMRB, and they're kept up to date. So if you're using the latest version of Civil 3D UKIE, it has the new CD 109 standards, for example. There's the equation for calculating the required length of a transition curve. All of that is built into the UK country kit. So you should be able to generate really good geometry for your super elevated roads. So you'll have a normal crossfall here and a super elevated curve with a smooth transition between the two. That's what we're going to design today. These standards are for both horizontal and vertical geometry as well. You'll find them in the same place in your profiles. Just go to the Design Criteria tab, and that's where you can set up your standards. Now, if you've got the latest version of Civil 3D 2021 UKIE, then these have all been updated again. And the design check sets are really good. They're far better than they have been ever in Civil 3D. Super elevation can be calculated automatically or manually applied. I think the best way forward here is probably to get the software to calculate it. Then you get a nice, neat table that you can edit to your heart's desire. You can use that super elevation table to work on small site roads as well that don't use these standards. So, for example, here where the lie of the land makes it better to have a single crossfall after the bend, for example. Here's the normal crossfall. I've not designed any transition curves, so there's got no tables to look at. We haven't got any design speeds on there. We just want to set a single crossfall after a set chainage and transitioning over a set length. So we'll have a super elevated section like this with a single crossfall after this bend, for example. We can use the table and just add in the transitional region and set the chainage and crossfalls. We'll have a look at that too. Okay, so I think we'll just crack straight on. Let's escape out of that and minimize that. And here we go. Right, so I'm going to just draw a alignment down the back of these houses here. It's just basically, it's near Birmingham, this. I'll just open that up. Click on it, there we are. So I'm just going to put a road around the back of here, okay? So we'll start with our alignment tools up here. So I'll do a alignment creation. I'll give it a sensible name. I'll just call it link road. Centerline alignment, start at 0. We'll just use the defaults. There's the design criteria. So I'll set it to 60 kilometers per hour. I'll stick with that. But I will design something outside of standard so we can have a look at what we can do here. We'll use the criteria-based design. We can either use the design check or the file or both. I'm going to use the file in this case. And we'll set the superelevation to 2.5% using transition curves. So we'll put some transition curves in there as well. So I'll hit OK. And I'll just bang the straights in first. So maybe we're going to link this dual carriageway here. Let's turn the snaps off. And we'll just draw down here, go across here, and then so I'll take it down or up. I'll take it up to here, like so. Obviously, I'd carry on. Now let's put the curves in. So if you're putting transition curves, so this toolbar here, you're probably all familiar with it now. So you've got all your straights there, all the different ways of designing straights with different constraints, fixed, floating, free. Then you've got all your curves here, fixed, floating, free, and that's what you do most of the time. The next 3 buttons are for transition curves. If you've got the American English, they call them spirals, but we call them transitions. The first one is putting straights with transitions on them. The second one is putting curves with transitions on them. And the third one is putting transitions with transitions on them. So we're going to put a curve with a transition on it, okay? So we'll do a free curve, transition curve, transition between 2 elements. So I'll select the first element, select the second element. It's always less than 180. Now, because I've set the design criteria to 60 kilometers per hour with 2.5%, it's telling me what the desired minimum radius is, 510. So that's where that data's come from. It's already reading that file. So I'll just accept that. It's also reading that file and calculating what the transition length should be. And it's come up with a value minimum 30.2. I'll just accept that. That's the transition in, transition out. Okay, so you can see I've got the green is the transition, the blue is the curve, the red is the straight. Let's go and do the other one. Let's design this one outside of standard. So I'm going to select the first element, select the second element, less than 180, and let's put this at 360. So immediately we should have a problem. Now the transition length I'm going to leave at the calculated at 510, and I'll show you how you can get it to recalculate it at 360. So we'll leave it at 30.2. It will be too short by the end of this, but the software will tell me. Transition out. And immediately I've got a warning symbol here, which is telling me what the problem is. Let's just open up the table view. There it is. So my radius is 360. It should be 510. And that little symbol there is telling me that there's a problem. If I hover it over here, it should tell me the minimum radius has been violated. Misses. So let's look at fixing that. So maybe, I mean, obviously we can change the geometry. So we can change it to 510, and that'll immediately fix the problem. So if I type 510 in there, the little symbol goes away, everybody's happy. But let's say you're constrained on that, and we're stuck with our 360. We can't go any more than that. Our other alternative is to lift the road further. So we'll super elevate to 3.5%. So let's do that. Now you can use this button here, which is your sub-element editor. This will open up a new panel over here. We'll select the element I want to edit, which is this curve. And there is our transition length. There is our curve length. And there's our transition out length. And we're using 2.5%. So this curve I'm going to change to 3.5. There we are. It's immediately fixed the curve radius issue, but it's giving me an issue now with the transition lengths. But that's fine, because in this table it's telling me what it needs to be. It needs to be greater than 42.8. So I'll just go in here and make it 43. Go down to the transition out, you'll see the symbol disappear, 43. Job's a good one. Okay, so I'm going to go with that as my design. So the next job is we are going to do our profile. So we'll do a profile. Create a surface profile first. We'll pick our link road and the existing ground LiDAR. I'll just draw it straight. And I'll stick it over here. Keep it nice and neat. Like so. It is a bit wibbly wobbly, this area, so let's just design something. So profile creation tools. And again, we've got our design criteria tab here. So I'm going to use the criteria based design, but this time I'm going to use the design check tables instead of that file. And if we have a look in here, we can pick our single carriageway road, which is probably relevant for here. We've got minimum K values, dual carriageways and motorways in here. So I'm going to use the single carriageway road set. Hit OK. And again, I'm just going to start with straights. And we will put something in kind of here. Maybe go over to here, up to here. We'll go straight across there and to the end. Now immediately we have a violation. Okay, so basically for the single carriageway, it's a desirable violation, but it hasn't violated our relaxed rule. So we could probably get away with that. But if I just move this up, change that there, we're okay now. It's gone away. If I do something silly, it comes back. If I do something ridiculous, we'll probably have two violations here. There we are. So we've actually violated the desirable and the relaxed. Let's do nothing too silly. Okay, so I'll plonk it there. Let's put our curves in. So I'll do a free curve parabola. And in there, we've got our standards for K values. Okay, so I'll just type K to set the K value, and then I will set the input, okay, on there. So let's say I go 25. This one here, okay, I'm going to go 10, and we have a violation. Let's come back to that. This one here, I will go 10 as well, and another violation. So let's have a look at that violation. Basically, the desirable minimum sag curve has failed. So what I'll do is I'll just move this over a little bit, and I'll move that one over a bit more. And in the table view, let's fix it. So if I go, let's pan it over so you can see it happening. There you go. So if I go in here and set that to something that's more desirable for a single carriageway standard UK road, 17, and that's fixed it. Same here, 17, and that's fixed it. So the software is allowing me to do that, them standards, both vertically and horizontally. So let's build our corridor, and then we'll do our super elevation. Oh, by the way, for those of you that haven't got 2021 UKIE, we've got new band sets as well. So if I import the new band set, which is the UKIE composite band set, all you have to do here is that top row. This works very much like the sections of work, where everything is in the one row with offsets. So all I have to do is set that top row to my link road. That's my design. And profile 2 needs to be set to the existing ground. And of course, I've got my vertical geometry, so that needs to be set to my link road as well. Hit OK. Perfect. All set up. So the blue ones are my horizontal geometry points. The green ones are my vertical geometry points. We've also got a super elevation table, which is empty at the moment because I haven't actually designed it. So we'll come back to that. Right, let's build the corridor. So I'll go into the corridor modeling. Call it link road. It's an alignment, link road, version 4, assembly. I've got my full road 7.3. I'll target the surface in this case. I'll hit OK, and I'll not change anything. I'll just hit OK and rebuild the corridor. We'll have a quick look, check I've not done anything silly. So let's have a quick look at it. Yeah, that looks okay, like so. Okay, so at this stage, the corridor has a 2.5% slope on the left lane and a 2.5% slope, minus, sorry, 2.5% slope on the left lane and a minus 2.5% slope on the right lane. So what we now need to do is calculate the super elevation, and we can do that here. Now it's in the launch pad because this calculation is done on the actual alignment. We could have done this on the alignment, but I wanted to do it after we've done that. So let's put some contours on here so we can see what is happening to our road while we're doing it. Okay, so I'll put some contours on there. So I'll just put a surface and I'll just say paved top. It wants to be contours, so I'll just do 0.1, 0.5 proposed ground. Don't need overhang correction in this case, and we'll just use the pave. So it's only going to put it on the road. And we'll put a boundary on there, which is the road edge, which is the point code lane. Okay, hit OK, rebuild the corridor. So there is our contours, and you can see it's got a crossfall everywhere. There's a high or low point there, high or low point here, and then we've got quite a flat area there. Okay, so that's that. So let's go and calculate our super elevation. So I'll pick the corridor, do the super elevation, calculate. So in this window here, we can just open up the curve manager and do it ourselves, or we can just get it to calculate it. It makes sense to get it to calculate it. Now, this is the reason why you have to tell your assembly when you make it that it's either a single crowned or a planar or a dual crowned or a dual planar with a central reserve or whatever. So that's where you tell that. That's where it matches your assembly. So we'll hit next. It's symmetrical in this case, that's fine, so we'll leave that ticked. It's 365 wide on the right and 365 on the left, and it's got a normal crossfall of minus 2.5%. We don't have shoulders, so we'll uncheck that. And in here, we're going to calculate it at 3.5, because that's the maximum. So when it sees the curve at 3.5, it will calculate that one at 3.5. Then it'll see the curve at 2.5%, and it'll just calculate it at 2.5%. So I'm happy with that. Curve smoothing is just a vertical smoothing. I'll turn it on, you won't see anything happen. And we don't have any overlap, so we're not going to likely get these curves to overlap. But if you do have curves, transitions that are overlapping, it'll resolve them. But it has to do it on the entire alignment, so you may have to break that up. But I'm happy with that, so we'll just hit finish. We get our table up, which I will make a bit bigger. And in our table, you can see here, it's calculated where all the super elevation is. So we've got our run out and our run off. So that ends the run off. Run out ends your normal 2.5 minus 2.5. It goes to a level crown. Then it starts raising the right hand, the left hand lane. Note it's always the left outer lane if you've only got one lane. And then let's go to curve 2, and you should see there it is, 3.5%. Okay, so plus 3.5 minus 3.5. So that's good. I'll just pull this back down because when we do the next one, I'll want it long and thin. And okay. It adds these wedges in so you can physically see. Now, these are just a label in the alignment label set. Okay, so if I went into the alignment, no, idiot. There you go, into the alignment label sets. It's just this one here, these wedges. So again, you can make your own styles of them or just remove them. Entirely up to you. So you can see where that is, but you can see the contours haven't been applied yet. Why is that? Because we, by default, set the corridor not to auto-rebuild. Okay, so you should see these contours change when I rebuild the corridor. So I'll go in and rebuild it. And there they are. And there is our nice crown to single crossfall, back to crown, then up to a single crossfall, and then back to crown. Okay. If you do get wibbly wobbly contours, just edit them. So if I just turn on triangles, you can just edit them or just ignore them. Swap edges. So this one's a bit wibbly wobbly, so swap that edge. Let me turn selection cycling off like so, and we can swap these to give us straighter contours. Okay, so you can adjust them to your heart's content, really, where you've got these wibbly wobbly bits. That one, let me do that one. That one's a bit wobbly. Okay. Okay, so you can straighten out the contours with just a simple edit. Normally I'd spend probably a little bit longer doing that. But I'll go with that for now, so that's good. Let's just check it in the section view. So we'll use our section editor. Let's get to the first curve. So the first curve starts at chainage round about 170. So that's what it looks like. So let's go to chainage 170. Oh, I've gone a little bit too far. So you can see you've got your normal crossfall here. Let's zoom in a bit and set that to offset and level. Okay, and you should see the left lane start lifting. Beautiful. As I'm going through that, up to a full 2.5% around the bend. Let's pan that down. And then it should start lowering. Oh, I need to reset that, don't I? And then it should start lowering after the bend. There we are. You can see it start lowering. Let's go to the next bend. Oh, it's not far away, is it? Offset and level. So there we are, left lane starting to lift. You should see them both lift up to 3.5%. There we are. So we've now got a 3.5% slope, and then it starts bringing it back down again. Okay, brilliant. So we can use our standards, we can use the standards file, we can set the super elevation, but as I say, the key thing here is making sure that that assembly, we go to the assembly properties, is set to single crown road or a dual or a planar or whatever you're doing. And that sub-assembly has super elevation switched on. That's quite a nice add-on there, actually, if you think about it, because if I want to remove the super elevation, I just switch that off, rebuild the corridor, job done. So it makes it easier. Okay, let's have a look at a normal site road. So if you're doing like housing estates and stuff like that, you'll often go from a crown road up the hill, and then you turn around a 90-degree bend, and you're now on the, you could do the planar road in there. So here's a standard crown road. So let's do the same with this one. I'll just rebuild it now. Okay, and what I'll do is I will go into the corridor properties. Selection cycling. There we go. Corridor properties. No, we'll do the super elevation. So rather than calculating it, because there's no design standards on here, so we haven't got any table lookups. There's no design standards on here. We're just going to manually do it. So this is where you can just go into the tabular editor, pick your alignment, site road. There's the tabular editor, and that is empty. So we'll add in a geometry. Now we want to start at 0 so we can tell the software at 0. You can see when I've rebuilt it, it's flattened the lanes. I'm going to set the start point at 0. So I can say from 0, so if I expand that, transition in, manual chainage, so I'll just put start. So from 0, the left outside lane will be minus 2.5, and the right outside lane will be minus 2.5. And then let's say around 60, we want to start to lift, okay? So I'll go in and I'll add another chainage, and I'll just type 60. Okay, so there's where the curve starts. We're at 60. So at 60, that's where I want to start super elevating. So the start point, it wants to be minus 2.5 again, doesn't it? Minus 2.5 on the left outside lane, and minus 2.5, 2.5 on the right outside lane. Okay, let's go and add another one in, and this time we want to do it at 70. So we're going to have a 10-meter transition. Okay, oh, I better rename that one, haven't I? So end crown. Start super elevation. Okay, so at 70, I want the left lane to stay at minus 2.5, and I want the right lane to go to a positive 2.5. Okay. I then need to tell it at the end to be at minus 2.5 plus 2.5. So I'll add another region in, which will be the end of the road. So I need to pick this end chainage. Okay, and that will be my transition out area. Okay, so continue SE. And that wants to be minus 2.5 and plus 2.5. 2.5. Okay. So let's see what happens when I rebuild the road. Look at your contours. And there we are. So there's my crown. And then it starts to super elevation over a 10-meter period. And then now we've got a single crossfall. Again, let's just double check it in the section editor. Shut that down. Okay, so we said we end, so when we get to 50, it's 2.5, 2.5, there it is. And then you'll start to see the lane lift. Oh, it was 60, wasn't it? Not 50, my mistake. So 60, and then we'll start seeing the lane lift on the right. There it is, slowly lifting to a positive 2.5, and it will stay at 2.5 right the way to the end. Let's go to last but one. There we are. Nice, simple tools to automate and also to manually set up super elevation for housing and for major highway design. And that, my friends, is it for the year. So if anybody has any questions, you can post them now. Or if you'd prefer, you can send me questions on email. But I thought I'd keep it nice and simple for the last one of the year, and you can all celebrate Christmas. Although I'm working all the way up to Christmas Eve. I don't know about you guys. I think a lot of people are making this their last day for Christmas. But no, I'm working up to Christmas Eve. So, but it is the last webinar of the year. I hope you've enjoyed the series. If you have any requests and you want me to cover anything else, then let me know. Dynamo is already on the list. If anybody's asking that. No, no questions. It was nice and clear then. That's good. That's what we like to see. Oh, hang on. We have a question. Yeah, so the last few webinars, yeah, they're all on the website, on the on-demand area, apart from last week's. As of this morning, it hadn't actually been posted, but it will be up there hopefully next week. All right, Nick, you're very welcome. Good, thank you, Gavin. I'm glad it was helpful. Okay, so thank you very much, everybody, for watching. Have a great Christmas and a great New Year, and I'll see you for the next set next year. Oh, hang on, we have a question. Can we get the super elevation profile view? So the super elevation in the profile view, it's already there. So let me quickly show you that. Remember I said it puts the super elevation in, we have that. There is our super elevation in the profile view. Okay, that's that 20-meter smoothing of the curve. It just does a vertical smoothing on there. So it's already in there, and you can make your own versions of this. And there's the 3.5%, so it goes up to 3.5%. So it's already in there, nice and easy. Cool. Okay, I will call that a day. Thanks again, and I'll see you in the new year.